تيست او اختبار قوة العزل لزيت المحولات. الاختبار ده هو بيعرفنا العزل بتاع المحول وخصائص العزل بتاعته قوية ولا حصل له تلف مع كتر الاستخدام. ده بيتم عن طريق تسليط جهد عالي على على عينة الزيت، وبنحط الزيت في جوه وعاء. الوعاء ده هو فيه كورتين معدنيتين زي ما هنشوف دلوقتي. الكورتين ده هم بيبقى عليهم جهد عالي والمسافة ما بينهم 2.5 ملم. يلا نبدأ الاختبار واحدة واحدة. أول حاجة خالص لازم ننظف الوعاء بالزيت. نحط شوية زيت كده هوت ونبدأ ننظفه، وما حدش ينظفه بالمية لأن المية طبعا ولا شك بتأثر تأثير سلبي جدا على قيمة الاختبار وعلى قوة عزل الزيت. بننظف بهدوء خالص كده هوت اهو. ده جوه زيت وبننظف بالراحة. نضف الوعاء ونفضي الزيت اللي اتنضف بيه، ننظف أكتر من مرة. وبعدين نبص جوه هوت نلاقي الكورتين المعدنيتين اللي هو بينهم 2.5 ملم. هناخد بقى الجزء اللي تحت ده هوت نتعرف عليه ايه اللي جوه ده هوت. ده نقاط توصيل. النقطة ديت متوصلة بالكورة اللي على اليمين، المعدن اللي جوه ديت، والنقطة التانية المعدن ديت بتوصل الجهد للكورة اللي هي على الشمال اهو. الكورتين هنا همت المسافة ما بينهم 2.5 ملم. ده الكترودات الاختبار. هنحط الجهاز على النقط اللي هي دي. النقطة دي من المعدن برضو، دي اللي بتخرج لنا الجهاز، بيخرج لنا عليها جهد عالي. الجهد العالي بيكون بالكيلو فولت طبعا، والجهاز بيرفع فولت لحد ما يشوف الزيت هيكسر، العزل بتاعه هيكسر عند قد ايه. حطينا عينة الزيت اهيت وحطينا الوعاء في مكانه الصحيح، وبالطريقة دهيت بنختبره. نشوف الزيت اهوت والالكترودات مغمورة في الزيت. يعني حضرتك لما تحط زيت لازم تكون الالكترودات دهيت مغمورة تماما في الزيت. واما الجهد يوصل مرحلة معينة بيكسر العزل الخاص بالزيت، وبيعدي الكرنت او التيار ما بين الكورتين دولت. وفي الحالة ديت بنعرف القيمة اللي هي القيمة بتاعة العزل الكهربي بتاع الزيت. يبقى إذن الزيت ده قادر على إنه يعزل جهد لحد كذا كيلو فولت. طبعا هنقفل الجهاز لأن لازم يتحط عليه الغطا ده هوت، من غيره ما بيشتغلش. كان نفسي أوريكم الشرارة الكهربية اللي بتعدي ما بين الكورتين، الشرارة اللي هي التيار يعني. طبعا هنبدأ نشغل الجهاز ونشوف التست وهو بيتم. خليكم معانا. بصوا العينة طبعا محطوطة جوه هيت، والجهاز بدأ يحمل اهوت. ده طبعا الاعدادات الخاصة بالجهاز. بنحدد له قيمة الستاندرد اللي هو شغال عليه او المواصفة اللي هو شغال عليها، وبنحدد له بعض الاعدادات، نوع الزيت والالكترودات اللي هي مستخدمة. ده الستاندرد طبعا اللي هو شغال عليه. رقم المواصفة IEC مش عارف رقم 60 كام كده. وده نوع الزيت، ودي المسافة اللي بين الكورتين اللي هي 2.5 ديت مليمتر. وهنا بيحدد نوع الكورتين. هنتكة تيست. الجهاز طبعا هيستنى لمدة 5 دقايق على ما يكون أي فقاعات هوائية في الزيت راحت، لأن هو ما ينفعش نعمل تيست وفيه فقاعات هوائية. أنا طبعا جريت وبدأت على التيست على طول. نلاحظ إن الجهد بيرفع اهوت 11 كيلو، 17، 18 كيلو، 20 كيلو فولت. طبعا هو بيفضل يرفع القيمة دهيت، يرفع حتى الآن الزيت عازل المسافة اللي هي ما بين الكورتين ومستحمل العزل ده، هو مستحمل الجهد ده هوت. ما زال الزيت مستمر اهوت 53 كيلو فولت، 57 كيلو. التست تم واستحمل 57 كيلو فولت. طبعا الجهاز بيعمل التست اكتر من مرة، 6 مرات تقريبا اهوت. كاتب لك تست لو 1/6 اهوت. وقيمة النتيجة بتاعت أول تيست كانت 57.1 كيلو فولت. هو هياخد 6 قراءات وياخد المتوسط بتاعهم. ده التيست التاني اهو كمان مرة. نلاحظ إن القيم بيرفع الكيلو فولت اهوت. وده التست رقم 2. هو كاتب لك تيست 2 اوف 6. اما يخلص التستات كلها بياخد القيمه، هنشوفها مع بعض دلوقتي، ويديك النتيجه بقى، الخلاصه بتاعه قيمه العزل بتاعه الزيت دهوت، وتعرف تستخدمه ولا لا. طبعا مفترض ان النتيجه الطبيعيه ده 51.3. ده التست الثاني. هيعمل التست الثالث والرابع والخامس والسادس وهكذا لحد اخر تيست خالص. ده اخر تيست. انا ايه ما حبيتش اخليكم قاعدين قصاده يعني. هو بيفصل ما بين كل تيست وتيست دقيقتين بالظبط. هنشوف مع بعض دلوقتي ان شاء الله قيمة العزل المتوسط بتاعة الزيت، وبناء على القيمة دي بنعرف اذا كان الزيت ده هو صالح للاستخدام في المحولات ولا لا. الطبيعي ان الزيت المحولات قيمة العزل بتاعته بتبقى 30 كيلو فولت لكل 1 سنتيمتر مسافة يعني. هنا النتيجة النهائية بعد ما عمل التستات كلها اهيت اهو. القيمة المتوسطة تيست او اختبار قوة العزل
When your business requires an uninterrupted power flow, you need to trust that your equipment will be there to perform. Load testing is the only verifiable method to determine the actual capacity of your battery strings. From our simple constant current load banks to our advanced smart load banks, Eagle Eye's expansive, simple-to-use model offerings cover a range of 10 to 480 volts DC with discharge currents reaching over 1,000 amps, so you can rest assured we have you covered. Our systems are designed for all types of load testing: AC or DC, batteries, generators, UPS systems, or just general power supplies. Eagle Eye's load testing systems are rugged, reliable, and user-friendly. Our comprehensive range of DC load banks have design features to help cut down on your maintenance time and costs. You get real-time data of individual cells and string health with report generation. Our smart load banks maintain constant discharge throughout the entire test without manual adjustments. We offer many safety features like inline circuit breakers, fuses, and thermal shutdown. Each unit includes adjustable safety discharge cutoffs based on string voltage, cell voltage, capacity, and time. While load testing is critical, it doesn't have to be cumbersome. At Eagle Eye, it's our goal to provide products and services to make your job easier. For any critical power test and measurement requirement, consult Eagle Eye, a provider of battery monitoring systems, load banks, and handheld testing solutions.
This is the Yelloco Series YH-ZYD R30, 1800 liters per hour, double-stage vacuum transformer, oil regeneration, and oil purifier machine. Usage and operation. Place the equipment on horizontal ground smoothly. Connect power cables. Fasten all wiring terminals in the electric control cabinet. Connect the inlet and the outlet of the oil pipe. Open oil inlet valve and oil outlet valve. Automatic operation of products. Startup procedure. Turn the automatic manual knob switch to the automatic position and press the start button switch. Under the control of the Programmable Logic Controller PLC, the equipment will orderly control various motors, heaters, AC contactor, and other components. Shutdown procedure. In the automatic operation state, press the stop button directly, and the equipment will stop working orderly under the control of Programmable Logic Controller PLC. Operation procedures of oil purifier equipment, manual operation. Startup procedure, manual operation. Turn the automatic manual knob switch to the manual position and press the start button switch. Press the vacuum pump control button when the vacuum pump is in operation. The indicator light of the vacuum pump control button will be on. When the vacuum gauge display value is less than 4500 PA, press the Roots pump control button. When the Roots pump works, the indicator light of the Roots pump control button will be on. When the vacuum gauge shows a value less than 100 PA, open the oil inlet valve and oil outlet valve V1.1 and V5.2 according to the oil pipe connection, set as A in and B out. Note, the operation method of the valve. Turn the handle clockwise to close and counterclockwise to open. When the handle position is parallel to the shaft, the channel is fully open. When the handle position is perpendicular to the axis, the channel is fully closed. When the oil level in the vacuum separation chamber rises to the middle of the observation mirror, press the oil pump control button. When the oil pump is working, the indicator light of the oil pump control button will be on. Press heater control button to start heating. Shutdown procedure, manual operation. Turn off the heater first. Press the heater control button. Close the oil inlet valve V1.1 after 5 minutes. Stop the Roots pump. Stop the vacuum pump. Stop the oil pump after the transformer oil in the vacuum separation chamber is drained out. Close the oil outlet valve V5.2. Cut off the product power switch. Cut off the user power switch. Regeneration device operation. If you need to use the regeneration device, please open switching valve V5.5, V5.6 first, then close switching valve 5.8. If you don't need to use the regeneration device, please open switching valve 5.8 first, then close switching valve V5.5 and V5.6. If you find the oil storage tank has too much oil, please open permeation valve to release vacuum first, then open drain valve to drain oil out. When finished, please close permeation valve and drain valve.
My name is Ed Cunning. I am the Eastern Regional Manager for AEMC Instruments. Today we're going to talk about the micro-ohmmeter, the model 6250. There are two devices that are used to measure resistance: a micro-ohmmeter and a insulation tester or megometer. These are often confused because they are both measuring resistance. In the case of the micro-ohmmeter, which we're going to cover today, we are effectively on the right-hand side of the decimal point. And here we see the decimal point, and as we get more and more sensitivity, lower and lower resistance, we see the engineering units change from centi, milli, all the way down to micro, which is 5 decimal places. In contrast, with an insulation tester where we want to measure very high resistance insulation capabilities, we find ourselves going more and more on the uphill side of the decimal point, if you will, and getting into megometers, for example, which is quite common. The AEMC model 6250 micro-ohmmeter is unique in that it can measure out to 0.1 micro-ohm. That is extremely sensitive and probably perhaps the best in the industry. It can measure up to 2,500 ohms, so it does have a broad range, although normally it will be measuring down into the very low ohm resistance. It has test current capability because when we're testing a junction or bond, we want to pass current through that bond to stress the connection, if you will. One can walk up to 2 whisker 20 gauge wires touching and measure with a classic ohm meter, and you'll read 0 ohms. That is not a good connection. It will not support any kind of current, and in the case of lightning protection, things like that, you want something with a excellent bonding capability, very low resistance to carry away a lot of energy. That is why we have test currents available from 1 milliamp clear up to 10 amps. We're going to stress this bonding connection where 2 particular pieces of metal are touching, be it welded or be it a cinch down or torque down lug and a bus bar, for example, in the case of power wiring. Okay. It has several additional features that are unique to this product. It has a sensor input capability for a thermistor bead to measure ambient temperature. Because we know that as temperature rises, increase in resistance will also occur. So if we're really wanting a very true reading, we must take the temperature into consideration. Because for every 10-degree rise of temperature, we will see the resistance will actually double. We also have a remote probe that can plug in here, come out, and actually touch the test specimen. So we have a localized temperature input at that point. Okay. These are optional RTDs. We have selectable metal types because different metals will exhibit different resistance ranges, again, as a direct function of their temperature. We have 4 of the classic ones in here, for example, copper, steel, aluminum. However, if you do know the alpha, which is the engineering unit for resistance for that particular metal, you can actually dial that in this instrument. It has an automatic or manual temperature compensation. It has 2 alarm programmable set points where if it exceeds high or low above a desired resistance range, it will flag an alarm. It stores up to 1,500 test results. Now, to keep these in neat order so we know where they are and what they are, they will actually increment. They will give us a label of object and a number, and a test and a number. For example, if I was to test a 3-phase transformer, I would call that transformer object number 1, and as I tested A phase, that would be test 1, B phase would be test 2, C phase would be test 3, for example. And I can store 1,500 sets of those readings. Okay. I have selectable inductive or pure resistance test. because we know that when we do an inductive test, we have to keep the test signal present for a protracted period of time before the inductive reactance settles down and we get a true reading. If I do know it's a pure resistance, then I can just activate the test. It will automatically activate the test and shut itself off and wait for the next test. This brings up another interesting feature. It can be set to automatically increment the test number to the next number. For example, if I have a lot of tests to do, I can be on object 1, I can do test 1. When I remove the leads and place them back on again, it will automatically increment to test 2. Remove the leads, go to the next test point, test specimen, it'll increment to test number 3 automatically. That is a unique feature also to this device. It has a large backlit display, and we can show that by turning it on, selecting any channel, and selecting the light to backlight it. Now, first we see the multiple scale selection. Starting with 1 milliamp, we can increase it to 10 milliamps, 100 milliamps, 1 amp, 10 amp, and again 10 amp. With each incremental step, not only are we increasing the current that's going to be driven through the test specimen, we also will be increasing the accuracy, or the number of decimal places that will be displayed. We see that, for example, we have a warning buzzer. We can toggle that on and off to save the battery. If we had selected alarm, we would see that here. This will tell us what range we have selected, 250. So if I go to 100, we'll see that change to 100, and I'm on the 25 ohm scale. It tells me the test current is now 100 milliamps. This tells us we are in the resistive mode, but I can toggle that back and forth into the inductive mode, or I can go to the auto mode. Okay. This is where I'll be moving it from test to test. And we'll notice that we get more decimal points the further up we go, the more sensitive we get. Okay. And it'll automatically change from ohms, in this case, to milliohms. So we'll get automatic adjustment of the range. We'll notice that it is in standby, so when I hook up to a test specimen and activate the test, you'll see it operate and go to standby. We'll start on the low scale, which allows us to only put 1 milliamp through this bonding connection, and it allows us to read very high range up until 2,500 amps, as high as 2,000. Well, we know it's going to be pretty low, but let's walk our way up and do a reading. First of all, it tells us we're on the ohm scale and we're only at 1/10 of an ohm range. Now that tells us that we are further on down scale, so we'll move it up with more sensitivity. We'll run a little more current through here, 10 milliamps, and try again. Aha, we're still reading all zeros, so it says that we have 0 ohms resistance, very low. Let's crank up the test signal to 100 milliamps. Now notice you get the operator and immediately it'll go back into standby. We're still reading all zeros, so it says we're way low. Let's go up some more to more sensitivity. We'll pump some more current through it, and it just automatically changed into the milliohm region. Okay, we'll do a test. And aha, now we're reading 2/10 of a milliohm rather, excuse me. And we'll crank it up some more. Now we're going to run 10 amps through it. We shift the decimal places, and we find, no, it's not 0.2, it's actually 2.1. But we still have some further sensitivity we can test, and we can run it up to to 10 amps, but at 25 milliohm scale. So we just increase sensitivity by a magnitude of 10. We're still at 21, and let's finally run 10 amps through it and read it. Aha! We are reading 0.2093 milliohms, which effectively is 209 microohms, and it's 209.3 microohms. So we see the sensitivity of this device as we increment up the scale, pump more current through, and increase sensitivity. Now at any point in time I can hit the mem button and store that, and again it will be object 1, test 2. My next test will increment to object 3, and so on. This instrument comes with a software package, which is the universal data view software that AEMC has that will operate across a broad spectrum of our test instruments. Okay. So now we'll conduct a new test. We'll move it to the 10 amp position, and we will go ahead and test. This conductor is actually very good because it is 0.004 microohms. Okay. So that just demonstrates the sensitivity of this meter. The recording capability is unique. The fact that we can take temperature compensation in for very difficult and precise measurement is unique. The fact that I can see the test take place is unique. The fact that I can make multiple tests and automatically reset and log and test each one of those is unique. So we see we have a lot of unique features that will help you perform your test, both accurately and with record and hard copy. We know with ISO 9000, in many cases we have to document our test. This will actually provide a documented list of our tests.
It has true RMS AC and DC voltage measurement facility as well. Using an MIT 485, what I'm going to do now is a demonstration of the insulation testing, continuity testing with a buzzer, and I'll also show you the test inhibit, which occurs if the product is inadvertently connected to a live supply. For the purpose of demonstrating the insulation test, I've connected a 25 megohm resistor between the red and black crocodile clips. So first of all, we select the test voltage. In this case, I'm going to select 500 volts and then simply press and hold the test button. And you can see displayed there the reading of 25.1 megohms, both digital and on the analog arc, and then above it a reading of 551 volts, and that is the actual test voltage. Okay, so that was the insulation test. Now let's look at the continuity measurement range with the buzzer. To measure continuity, you should first null out the test leads. To do that, we connect them together with a path of minimum resistance, and we select the continuity range. You can hear the buzzer because the leads are connected together. So we can see a reading of 0.01, which is the resistance of the leads, but If we press the test button, we'll null that out and we can see the null symbol has appeared in the display. So let's just turn the buzzer off and place the clips across a 5 ohm resistor. And without having to press the test button, we can see now that it's just measuring fractionally over 5 ohms with an output current of 205 milliamps. We're now going to have a look at the test inhibit function. All of the products in the MIT 400 family are protected against accidental connection to a live mains supply, and I'm going to show that to you now. So here I have a mains lead which is connected to the device. Let's switch it to continuity range. It will read open circuit. I'm now going to simply plug it into the mains. Now you'll see that the product immediately warns you of a live voltage by repeatedly sounding the buzzer, and it automatically changes to a voltage range showing the actual voltage that's present. Now I can push the test button, I can select different ranges, and it will not damage the instrument, and more importantly, it won't damage you. Now, what makes the MIT 400 series superior to virtually every product on the market is this. If I initially
begin energy logging, start at the meter screen, select Change Configuration, and choose Energy Study under Study Type. Now choose Topology and select your circuit type from the list. Other settings, such as where the current and voltage transformers are installed, can be selected to ensure all measurements are shown correctly. Now it's time to install the 1730 at the load. Where you install the 1730 will depend on what savings you're looking for. A good place to start is at the building's main service entrance. When installing, ensure the voltage leads go to the correct phases and that the iFlex current probes match the selection compared to the voltage channels. Once the power is back online, press the Verify Connection button. The instrument will let you know if things are correct or show where you may have made a mistake. If a mistake has been made, you can fix it on the instrument without having to disconnect anything using the Autocorrect button. When you press the Logger button, the last used or default settings are displayed. If you need to change these, select Edit Setup, then scroll through the menu to make the changes you need. In this case, we'll select Duration. Press Enter to see the selections and choose 1 day. The instrument indicates how much memory is available. Next, we'll select the average period. This is a period used to present the data on the trend graphs. If you're logging for an extended time, choosing a short average period will result in a larger file. Energy cost per kilowatt hour can also be selected to track your energy expense. Currency type can be changed in the settings menu. The file name for your logged data is automatically generated. In this example, it's es.019, found here at the top of the logger settings list. Now you're ready to log energy. A trend graph immediately starts to show the energy being consumed. While energy logging takes place, you can also check values like voltage and current. If you've selected a demand period, the first readings will be available once the first demand interval period has completed. Energy and cost reduction opportunities are there. Find them with the Fluke 1730 Energy Logger.